Hello everyone. In today's lecture, we'll be talking about serial communication, which is a data communication method in Arduino, which enables Arduino to communicate with external peripherals that we'll be talking about from here on out. So let me take an example of Arduino and a Bluetooth chip. So let's say that Arduino has been interfaced with the Bluetooth chip, which is in communication with mobile application wirelessly. So how is this communication between Arduino and the Bluetooth chip actually happening? So it happens serially, and Arduino sends data serially to the Bluetooth chip, which sends data wirelessly to the mobile application. And similarly, the mobile application sends data wirelessly to the Bluetooth chip. In order for serial mode of transmission, two wires need to be connected between transmitter and receiver module. So in our previous example, the transmitter could be Arduino or the Bluetooth chip, and the receiver could be the Bluetooth chip or the Arduino. And it is imperative that the serial data transmission pin, the pin from which the transmission is happening of the data, which is called the serial data transmission pin or TX of the Arduino or the transmitter module, is connected to the serial data reception pin of the receiver module, which means the RX, that is what it is called, which will receive the data at the receiver module, and vice versa, which means that the serial data transmission pin of the receiver module should be connected with the serial data reception pin of the transmitter module. So that is how two wires are required. So in serial communication, the data is being transferred in a bit by bit manner. So I'm sure that we're all familiar with what a bit is, and that is how serial communication works. So I'll not be diving deep into how these bits are transferred, but in microcontroller board systems such as Arduino, this serial data communication can take place with the UART module, which is inbuilt. UART stands for Universal Asynchronous Receiver Transmitter Module. And what this module allows is that it allows the transmission of data serially. So the hardware of the UART on the Arduino Uno board is on pin number 0 and 1. So pin number 0 is the RX, which is the serial data reception pin, and pin number 1 is TX, which is the serial data transmission pin. With the help of the USB port on the Arduino Uno, serial data can also be transmitted and received. So let's move on to the basic statements and the functions of serial data communication for Arduino. So first we have the serial.begin function, which you can see on your screen right now. So basically, the serial.begin function is used to initialize serial communication. And inside the brackets, you can add the speed. Speed is basically the baud rate. And what does baud rate mean? The bits transferred per second. So let's say that we are transferring 9600 bits per second from the Arduino to our external peripheral, and from the external peripheral to our Arduino. So we'll write here serial.begin brackets 9600, and note that the baud rate of the Arduino Uno and the external peripheral that we've attached it with should be the same. So if you're using 9600, then we're going to use 9600 on both the devices. So this is how we initialize the serial communication. This statement is carried out in the void setup function because it needs to be carried out once. So one more thing, the higher the baud rate is, the higher will be the speed of the data transmission. So instead of 9600, you can take it to be 11200. Or perhaps if you want it to be low, it can be 1200 bps or 2400 bps. So there are a lot of baud rates which you can see on your screen right now. So our next function is the serial.print function, and in the bracket we can write the value. So what this function does, it's used to print the data, that is in the bracket the value, on the serial port, which means that the data printed on the serial port, which we can easily see on the serial monitor that we discussed about when we were having a tutorial of the Arduino IDE. So that is where this data is being printed in the ASCII format. So the ASCII format is human readable, and we can easily make sense of the data. So I'll be showing you a few examples of what kind of data can be sent and how does this whole process look like. So here we are in the Arduino IDE, where we'll be actually writing out some statements using the serial.print function and see how we can access what we've written using the serial monitor. So as you can see here, I have connected my Arduino Uno board to my port over here, And so in the void setup function, as we talked about before, we'll be writing serial dot begin. So we'll be beginning serial communication at 9600 baud rate, which is sort of the conventional as far as the external peripherals that we'll be looking at. Now in the loop function, we can pretty much print any sort of value that we want to print on the serial monitor. So we can print strings, we can print characters, we can print numbers. So let's actually take an example. So let's print serial dot print, and let's print hello world and semicolon. So after I verify this code first, I will have to save it somewhere. So let's save it as test1. After saving this code and verifying it, we can upload it directly to our Arduino Uno. And now that it has been uploaded, we'll see when we open the serial monitor how hello world is being continuously typed out. So one thing that we can do over here is actually add a delay function so that hello world is actually printed out in intervals of 1 second, so that we can actually make sense of the data better. So, and let's just upload this code. So now that it has been uploaded, you can see how hello world is being printed. Now you might notice that how hello world is being printed in the same line again and again, and it might be difficult for us to actually make sense of the data if it's maybe numbers. So there is a specific function for this that we'll be doing in just a moment. So as I was telling you before as well, how we can print whole strings like hello world. So let's actually print a few values now. So let's say that hello world, let's print the number 34 and upload it. So once the code has been uploaded, when you go to the serial monitor, you'll see how 34 is being printed again and again at intervals of 1 second. We can also print characters. Let's just print the character A. So upon uploading this code and going to the serial monitor, we can see how A is being printed at intervals of 1 second. So now, as I told you before also, this feels a little cluttery because every time you print A, it's in the same line, so you cannot actually make sense of the data. So what we can do here, we can actually write serial.println. So what ln does, it institutes a carriage return, which means that every time you write serial.println, A will start with a new line. So let me just show you how this looks like. And now the code has been uploaded. So you can see how A, every time it is printed in new line. So it's really good if you're trying to use a push button, as we did earlier as well. And we'll be instituting this serial functions in the programming example that we just did in a moment. So over here you can see how instituting ln actually is rather beneficial. So here we are in Tinkercad, and this is one of the programming examples that we just discussed while interfacing push button with the Arduino Uno. So in the code section, let's start a serial data transmission and actually print the status and the state of pin 9 onto the serial monitor. So first of all, you need to initialize serial communication by using the serial.begin statement and set the baud rate as 9600. If you do not do this, then if you write serial.print in your void loop section, it will not work. So this is really important. So what we want to print is the variable var, which is storing whether or not the push button is being pressed as it is being connected to the digital pin 9 of the Arduino Uno. So in order to print this, what we'll be doing is we'll be writing serial.print, and we'll be also writing ln, so that whenever the new value comes, it's in a new line, so that we're able to make sense of the data better. And in the brackets, we'll be writing var. So with this, let's actually start the simulation. And let me just bring up the serial monitor here, and you will be able to see how it is showing ones and zeros. So the ones over here mean that the push button have not been pressed. So let's actually press this button, and you see how we're getting zeros in the serial monitor, which means that the push button has been pressed. Since this push button circuit is in the active low configuration, which we talked about in our previous videos. So this is how it looks like. So let's actually make this look a bit cleaner. And in order to do that, what we can do is that instead of just seeing these ones over here, we can actually write var is equal to 1, a variable. So let's write over here. Let's stop the simulation first and write serial.print var is equal to. So what will happen is that first, as the Arduino IDE goes through these statements, it will read them as the first of all, it will print var is equal to. And since we're not adding ln over here, as you can see, we will not move to the next line. Then immediately after that, it will write the value of the variable and move to the next line. So let's see how the simulation looks like now. So as you can see, I've started the simulation, and in the CL monitor, we can see that how var is equal to 1. This looks much cleaner and we're able to make more sense of the data. So let's say that we're interfacing the CL monitor with some sort of screen, maybe an LCD. So this will be really easy to infer the state of the pin 9, and thereby we'll be able to infer whether the push button has been pressed or not. So let me just press the push button once again to show you guys how var will become 0, and that is what is happening. So this is a cleaner way to actually print statements into the CL monitor.